polar coordinates. Here in this section, we want to be able to convert from rectangular coordinates to polar coordinates. We want to be able to relate x and y to some radii and some angle. So some radius and some angle theta. To do that, very straightforward. In that, we have a conversion formula. Here r is said to be the directed distance, theta the directed angle. So we want to go from x comma y to the polar coordinate r comma theta, where if you look at the right triangle here, theta, then x and y, x being the adjacent and y being the opposite. Here the resultant r. And so obviously cosine of theta is x over r, and so thus x is equal to r cosine theta. Sine theta is y divided by r, and so y is equal to r sine theta. And then tan theta is equal to y divided by x. And then from tan theta, if we had to solve for the angle would be theta is the tan inverse of y over x. And then understanding that this is a right triangle that we have, according to Pythagoras, x squared plus y squared is equal to r squared. And so from these, we can build and map from rectangular to polar, from polar to rectangular. Let's look at some problems. Plot the point in polar coordinates and find the corresponding rectangular coordinates for the point. Here, here the directed distance is 8, so we go 8 units from the origin at power over 2. So that's 90 degrees, so we're there. Now, what's the point? I like that. What's the point? Yeah, what's the point? So it says find the corresponding rectangular coordinates for the point. So if r is equal to 8 and theta is power over 2, then x is equal to r cosine theta. So this is 8 times cosine power over 2. Well, cosine of power over 2 is 0, so this is 0. Now y is equal to r sine theta, so this is 8 sine of power over 2. This gives you 8 times 1, we get 8. So the point is 0, 8, which is the same thing. And so this is the same as 8, power over 2. In these exercises, the rectangular coordinates of a point are given. Plot the point and then find 2 sets of polar coordinates for the point on the interval from 0 to 2 pi. So x equal 2, y equal 2, we're there. Now, x is equal to 2 and y is equal to 2. So we know that x squared plus y squared is equal to r squared. So we get 2 squared plus 2 squared is equal to r squared. So this gives this gives us 4 plus 4 is 8 is equal to r squared. So r is equal to 2 times the square root of 2. Now in terms of theta, the angle, we need the tangent. So tangent theta is equal to y over x. That's 2 divided by 2. So here we have tan theta is equal to 1. When is tan theta equal to 1? That's when theta is 45 degrees. This implies that theta is pi over 4. So they want us to find 2 points. Maybe I should change the color so we can see the direction. So here, but what about going in this direction? Just the opposite, right? So 1 point we have, and that is the point, the radius is 2 square root of 2 comma pi over 4. That's this point here. So what about the other point, this point down there? Well, that looks to be when x is negative and y is negative. And so here r would be negative, right? 2 square root of 2. And to get this point in reference to the angle would be pi plus the reference angle, where the reference angle is pi over 4. So here, that angle would be pi plus pi over 4. And so we get 5 pi over 4. So the other point would be negative 2 times square root of 2 comma 5 pi over 4. And those are 2 points on the interval from 0 to 2 pi. What about this one? With the same idea. So x is equal to negative 1 and y is equal to negative the square root of 3. So if x squared plus y squared is equal to r squared, so this gives us negative 1 squared plus negative the square root of 3 to be squared is equal to r squared. Gives us 1 plus 3, so we get 4 is equal to r squared. R is equal to 2. Now the point where they are now is in that third quadrant where x is negative and y is negative. So x is 1, y is negative square root of 3. Somewhere there. Well, let's use the tangent theta to see if we could get the angle. So this is negative the square root of 3 over negative 1. I'm going to write this as the square root of 3 all over 1. Now, to see that, when I was in school, I was given the equilateral triangle where all sides are equal. Each angle is 60 degrees. We set each side to equal to 2. Split this angle, and so we get the bisection. We get 1 and 1. Look at that angle there. Using Pythagoras, this is a right triangle. This side here would be the square root of 3. Can you tell that's a 3? Well, this angle here is 60 degrees, or pi over 3. So the tangent of pi over 3 is the square root of 3 over 1. So that gives us here the angle. This implies that the angle here is pi over 3. So so we have this point here And then the point opposite of it would be up here. So let's see. Now that point here, x is negative, y is negative. So this point we don't have in terms of the angle. Excuse me. This guy here would give us pi over 3. But to get this guy over here, it looks like we would need to say for this one, pi plus pi over 3. Okay. So if that be the case, then pi plus pi over 3 is 4 pi over 3. So the point there in terms of polar coordinates would be here, the resultant 2, r is 2, and then this angle here is 4 pi over 3. And then if we do the opposite translation, we get negative 2, and then the angle there is the pi over 3. It's too big. Dang gun it. Why did it do that? Okay, so now this guy's going crazy. Guess I better leave it the way it is. So the next problem, let's see, what else do we have? Convert the rectangular equation to polar form and then sketch its graph. Well, you can go ahead and sketch right now. This is a circle with radius 3. Convert to polar form. X squared plus y squared is r squared. That's equal to 9. So the polar form here is that r is equal to 3. Here, y equal to 8, you can graph that. That's just a horizontal line. And to convert that to polar form, we know that y is equal to r sine theta. So if that be the case, then we say that r sine theta is equal to 8. That's it. This is a parabola that tends in symmetry with respect to the x-axis, and it's going in the positive direction for x. Now in terms of polar form, y squared is r squared sine squared theta. That's equal to 9. X is r cosine theta. We can divide through by an r, divide through by the cosine. So that leaves us with r then we get sine theta over cosine theta. I know you're saying, what about the other side? I heard you. This sine theta there is equal to 9. So that becomes r times tangent theta times sine theta is equal to 9. And you can get the terms on the right side, and so that would give you cosecant r is equal to, I guess I better put it over here. So you could have r is equal to 9, 1 over sine is cosecant theta, and then 1 over tangent is cotan theta. So either one that's okay. Or here, convert the polar equation to rectangular form and then sketch its graph. This is just x squared plus y squared is equal to r squared 16. Just a circle with radius 4. What about this one? Well, since we know that sine theta is equal to, let's write it like this, y is equal to r sine theta. So sine theta is equal to y divided by r. So if that be the case, then we go back to the problem. We have r is equal to 3 times sine theta, but that's y over r. Multiply both sides by r, so we get r squared is equal to 3y. This implies here that we have x squared plus y squared is equal to 3y. Well, let's see, this is x squared plus y squared minus 3y is equal to 0. We complete the square with respect to y. So this is x squared plus y squared minus 3y. We take half of negative 3, so we get negative 3 halves. Then we square that. That gives us 9 over 4. We add 9 over 4 to both sides. So this is x squared plus y minus 3 halves to be squared is equal to 3 halves to be squared. This is a circle with center the center at 0 comma 3 halves with the radius 3 halves. That's a crazy 2 down there. Okay. So this one, that secant is 1 over cosine, so this is r cosine theta is equal to 3, but r cosine theta is x equal to 3. It's just a vertical line. So that should do it. Now, you can, several ways you can write this answer in terms of the computer. I think all of these are sufficient and they are equivalent. Thank you.